In this lecture, we're going to learn about the notion of span. Let V be a vector space, and let S, given by V1, V2, Vk, be a subset of V. If every vector in V can be written as a linear combination of vectors in S, then we say that S spans V. S spans V. For example, show that this set spans R2. Okay, so let U1, U2 lie in R2, where U1 and U2 are real numbers. Then we can rewrite U1, U2 as U1 times 1, 0 plus U2 times 0, 1. And this is a linear combination of the vectors 1, 0 and 0, 1. So S spans R2. Let's do another example. Show that S given by this spans M sub 2, 2, where M sub 2, 2 is the set of all 2 by 2 matrices. Okay, so let A, B, C, D be a matrix in M sub 2, 2, where A, B, C, and D are real numbers. Then we can rewrite A, B, C, D as A times this matrix plus B times this matrix plus C times this matrix plus D times this matrix. Okay, so S spans M sub 2, 2. Okay, show that this set S given by 1, 0, and 3, 0 does not span R2. Okay, to show this, we just need to find one vector in R2 that cannot be written as a linear combination of the vectors in S. So consider 2, 2. If we could write 2, 2 as a linear combination of 1, 0, and 3, 0, we would have this C1 times the first vector plus C2 times the second vector equals 2, 2. For some scalars C1 and C2. But then that means that C1 0 plus 3 C2 0 is equal to 2, 2. So we get this. And equating the coordinates, we get this. Okay. But here we have 0 equals to 2, which is a contradiction. Therefore, S does not span R2. Okay, because we found one vector 2, 2 that cannot be written as a linear combination of 1, 0 and 3, 0. Let's do another example. Show that S given by this show that S does not span M sub 2, 2. Okay, consider this matrix. If this matrix could be written as a linear combination of the matrices in S, then we would have C1 times the first matrix plus C2 times the second matrix plus C3 times the third matrix plus C4 times the fourth matrix equal to this. Okay, now multiplying the coefficient C1 into this matrix, we get this and do the same for C2. And so on. Okay, now add those matrices up. And we get this. Okay, now equating each entry, we get this. Okay, now form the augmented matrix for this system of equations. Try solving this by Gaussian elimination. So let's do row 1 minus row 2. Okay, now let's do row 2 minus row 3. And let's do row 3 plus row 4. Okay, notice that in this last row we have 0 equals -4, which is a contradiction. Okay, so the system has no solution, and therefore our matrix 1, 2, 4, 1 cannot be written as a linear combination of the matrices in S. So S does not span M sub 2, 2.